Hello out there, you are welcome to DaveTuts Academy, where we are devoted to building excellence, especially in the STEM subject. Our video today is going to be looking at the complete solution to one of the past questions on what we call the elective math or the additional math or the further mathematics for students preparing for their O-level, maybe grade 12, GCE, WAEC or NECO exam, GED or GCSE. So now we're going to be taking a walk through the old past question from the 2019 WAEC further math. So we are going to be covering quite a whole lot of things. Talk about indices. We are going to be looking at the equation of a line, Surds, arithmetic progression, trigonometry, resolution of forces, equilibrium of forces. We'll be looking at the probability, equation of a line and curve, the perpendicular bisector, quadratic equation. We're going to be looking at the Pascal's triangle and the binomial expansion. We'll be talking about the transformation of lines, okay, linear transformation that students always ask about so much. We'll be looking at the binomial probability. We'll look at rank correlation. We'll look at mechanics. We'll look at integration and differentiation. So these are just loaded for you to help you build that academic excellence that you have always been looking for, and we want you to just pitch in. Get your pen, get your biro, get your paper, get your calculator. Let's work this together. I always used to say this: you don't get mastery by just watching these videos. You get mastery by getting your hands dirty. I can even assure you, we are also getting better the more we work on this. So how much more you need to lay your hands on this and do them practically so that you can build the academic excellence. One final thing we need to talk about: if you are yet to subscribe to our channel, see, these videos are being populated out there so that you don't have any excuse for not making excellence in academics and subsequently for not making excellence in life. So go ahead, subscribe to our channel, click on the notification bell so that you can have access and information to all our videos immediately we upload them. Then if you find this video resourceful, if you find them useful at all, go ahead and share with your friends, share with your loved ones, tell them about DaveTuts Academy and the effort we are putting to make things better, to actually build excellence in students, and together we can achieve this mandate of creating a better tomorrow for the students that are coming after us. So without much ado, let's head over to our video for today. Here in this question on indices, we have to simplify 625 raised to power 3x over 4 minus 1 plus 125 raised to power x minus 1 all divided by 5 raised to power 3x minus 2. So what we need to first take note of is that looking at these numbers that are actually the base for this question, we can see that they are multiples of 5. Like in the first case, 625 is 5 raised to power 4. So we can have that power in bracket as 3x over 4 minus 1. Okay, then this plus 125 itself is 5 raised to power 3. Okay, so we still have x minus 1, and then we have this denominator, so you can see it's divided by 5 raised to power 3x minus 2. I can take a step further to say, in the first entity, I want to open up the bracket, so I can have this as 5 raised to power 4 times 3x over 4 minus 4 times 1, okay, plus 5 multiplied by 3x minus 1, okay. If I say I will open this bracket here, I will say I have 3x, then 3 times minus 1 is minus 3. Okay, so all of this still have the denominator standing intact. So this is 5 raised to power 3x minus 2. So if I have to open up this, we can see that 4 here can cut 4 here, and what we will have eventually is that we have 5 raised to power 3x, then minus 4, because minus 4 times 1 is minus 4, then plus 5 raised to power 3x minus 3. Okay, this is being divided by 5 raised to power 3x minus 2. So now this is where student will make mistake. Student will have the tendency to say, yes, in these two entities on the numerator, I can just factor out 1, 5, and then I can add all the power, and you are going to get it wrong if you do that, because look at this sign. This is not a multiplication sign, this is an addition sign. And in that case, what are we going to do? We can see that in those two entries at the numerator, we can factor out 5 raised to the power 3x minus 3. So what we are going to have is something like this. Now this is 5 raised to the power 3x minus 3. Now this is how we factorize. In the first case, we are taking out 5 raised to the power 3x minus 3. What is remaining? We still remain 5 raised to the power minus 1, because if we multiply 5 raised to the power minus 1 with this, the minus 3 and minus 1 will constitute minus 4. So we are on track, okay? Then plus, looking at this particular case, we can see that the whole of that entity is what we have factored out. So it's only 1 remaining here. Students, I hope you get this. Once you miss this step, there is no way you can really get this question again, okay? So divided by 5 raised to the power 3x minus 2, okay? So now in this particular case, even look at these two. They are quite similar too. So you can say, okay, instead of just saying I want to factor out, I can say this that I have here is nothing but 5 raised to the power 3x minus 2, okay, multiplied by 5 raised to the power minus 1, because if I take only one 5, I can solve this to say it is now a singular 5 raised to the power 3x minus 3. That minus 3 is the addition of minus 2 and minus 1. So this expression and this are quite the same. I'm doing that because I'm going to divide with this denominator that I have. Then I have what I have here in bracket, and 5 raised to the power minus 1, which is the same as 1 over 5 plus 1. Okay, then we have the denominator as over, what do we have here now? 5 raised to the power 3x minus 2. You can see why I was factoring that out, because this entity and this entity, they are going to cross. So what I'm going to have is 5 raised to the power minus 1 is 1 over 5, that is this entity, multiplied by 1 over 5 plus 1. Here I can find the LCM to say that is 5. So here 5 can go in 5 1. 1 times 1 is 1, plus here is as if we have 1 over 1. So 5 divided by 1 is 5. 5 times 1, this is 5. Okay, so this is going to be 1 plus 5 is 6, and 5 times 5 is 25. And you can see how our attention to details have been able to enable us to see that what we have here is a positive sign, okay? And initially when we have opened up the bracket, we can see that we can factor out 5 raised to the power 3x minus 3, and you could have chosen to factor out 5 raised to the power 3x minus 2, so that from both numerator and denominator straight away you can cancel out and then solve to arrive at your answer as 6 over 25. All right. In this question, the equation of a line, we are asked to find the coordinate of the point which divides the line joining point 7, minus 5 and point minus 2, 7 externally in the ratio 3:2. So we need to know this. We have to divide the line externally. So we are looking for a point in which if we bring it to the line joining this 7, minus 5 and minus 2, 7, that point would divide the line joining these 2 points in the ratio 3:2. So I want to present a graphical view of how this is going to look. So here you can see I've located the point 7, minus 5, and I can tag that as point A here. So this is point A, and then the point minus 2, 7, I will say this is point B. And now we are looking for another point which will divide the line joining the two of them. So first, let's get that line. You can just go to point A and draw a straight line. Okay, so that's the line joining the 2 points. But now we are looking for another point which is going to divide this in the ratio 3:2. So to divide this line externally in the ratio 3:2 means that we are going to have something like this. Between the point C and the starting point, which is A, that's going to be a threefold division, and then between the point C and the second point, this is going to be a twofold division. So this is like 3:2. Okay, so in that case we will say from here, from C here down to A, so you can have this as M, which is 3. That's why we have ratio 3:2. And then from C to the second point B, if we just note that from B here to C here, that will be N, which is 2. So this is the way to externally divide a line. So once we understand this, we can now use the general formula that is used to divide a line in the ratio, as we're given here that the coordinate of point C will be M multiplied by x2 minus N multiplied by x1 over M minus N. That's going to be the x coordinate. Then for the y coordinate, we have it just symmetrical like that. M multiplied by y2 minus N multiplied by y1 over M minus N. Okay, so this is what we ideally will use to solve for this particular question. And from what we have been given, we are told that we can see that M ratio N is 3:2. So M is 3 and N is 2. Then the coordinate of our first point A, okay, which is x1, y1 is 7, -5. That is the starting point. Okay, so this is 7, -5. This is -5. Okay, then the coordinate of the point B, which is the second point, that's x2, y2. That will give us -2, 7. Okay, so having this, we can just substitute in the equation to have C to be, what's the value for M? That is 3. x2 is -2, so 3 times -2, then minus N is 2, multiplied by x1 is 7, okay, over M minus N, that's 3 minus 2, for y we have M, which is 3, multiplied by y2 is 7, minus N, which is 2, multiplied by y1 is -5. So then don't forget to put in your sign. It's not 5, it is -5, then divided by M minus N, which is 3 minus 2. So if we have this, we can just evaluate. 3 times -2 is -6, -2 times 7 is -14, over 3 minus 2 is 1. So that's the coordinate for x. And here 3 times 7 is 21. Then -2 times -5, the negative signs will multiply each other to become plus. 2 times 5 will give us 10, over 3 minus 1, that is 1. So this is -6 minus 14 is -20, and we're having 1 as the denominator. 21 plus 10, that is 31, and we're having 1 as the denominator. So the coordinate of C, okay, that's going to divide this line externally in the ratio 3, 2 is equal to -21, 31. So that's the coordinate as we are asked, and you can see it is just, yes, the x coordinate is moving more in the negative direction. Here you can see in the negative direction, and the y is moving more in the positive direction. So we are quite on track, and this is how we divide a line externally as given in this type of question. All right. In this question on Surds, we are told that without using calculators or mathematical tables, we are to evaluate 2 over 1 minus root 2 minus 2 over 2 plus root 2, and we are to leave the answer in the form p plus q root n, where p, q, and n are integers. So we are going to be doing that, and the very first thing we can do looking at this expression is that we can find the LCM, which is going to be, in this case, the product of the two denominators that we have there. So if you have our line there, we can say we want to find the LCM as the product of 1 minus root 2 multiplied by 2 plus root 2. Okay, then for the first case, in the first entity, if we look at this denominator and we use it to divide this, it will remain this other entry from the second entity. So we will have 2 multiplied by 2 plus root 2, then minus 2. Just like we did in the first case here, if we divide this denominator by 2 plus root 2, it will remain 1 minus root 2 multiplying these 2. So we have 2 multiplied by 1 minus root 2. So this is what we just need to evaluate. First, for the numerator, we can open the bracket. 2 times 2 is 4. Then 2 times root 2 is 2 root 2. Then here, we should note that this negative sign is multiplying all of the entities in this particular expression. So we have minus 2 times 1 is minus 2. Minus 2 times minus root 2. The negative signs will multiply each other to give us plus. So 2 times root 2 will be 2 root 2. Okay, then we'll still have our denominator to express. And here we can open up the bracket by multiplying entity wise. 1 times 2 will be 2. Then 1 times root 2 will be root 2. Then minus 2 times 2 will be minus 2 root 2. And minus root 2 times root 2. When you have a square root, okay, here we are using 2. And we are multiplying it by each other, meaning that we are squaring it. This is the same by the law of indices, is 2 raised to the power 1 over 2. Then this 2 times 2. So the 2's will cut out and this will be 2. Okay, we need to know this so that we can apply it here. So that's one of the rules of indices that normally help us to solve questions like this effectively. So in that case, this last entry will be minus 2. All right. So looking at the expressions there, we can see that 2 minus 2, that will be out of the equation, so that we are going to have here 4 minus 2 will give us 2. Then 2 root 2 plus 2 root 2 will give us 4 root 2. Then we can divide this by what we have as the denominator. So here root 2 minus 2 root 2 is going to give us minus root 2. It's as if you're having x minus 2x. So x minus 2x is going to give us minus x. So x can be taken as root 2 in this case. So we have root 2 minus 2 root 2 is going to give us minus root 2. So once we have this, we can now say we want to further work on it. Say, since we are told to express it in the form p plus q root n, so we can find the conjugate of this by multiplying both numerator and denominator by minus root 2. So I'm going to have 2 plus 4 root 2 over minus root 2. But I want to multiply it by, okay, I can just say let me multiply by root 2 over root 2. I have expressed this initially before, that this is going to give me just 2. I'll just note the negative sign. So that is going to give me 2 times root 2 is 2 root 2 plus 4 times root 2 times root 2, okay, over minus root 2 times root 2. And I've expressed that when you are multiplying root 2 by itself, that's going to give us 2. So this is going to give us 2 root 2 plus 4 times root 2 times root 2 here will give me 2, okay, divided by here root 2 multiplied by root 2 is 2. So we still have the negative sign, that's minus 2. So if I can just break it out, that will give me something like 2 root 2 over minus 2 plus 4 times 2 is 8 over minus 2. So the final answer after having expressed all of this is going to give me minus 2 can cut 2. So I will have, okay, that will be minus root 2. Then 8 over minus 2 is minus 4. But if I want to write it in this order, p plus q root 10, that will be minus 4, okay, minus root 2. So this is going to be the final answer to this question that we are asked on Surds. In this question on arithmetic progression, we are told that how many terms of the series minus 3, minus 1, plus 1, and so on will add up to 165 degrees. Now, to look at this question holistically, we need to notice that we are being given the set of values of this particular series as minus 3, then minus 1, then plus 1. And if we look at this, we need to get the next set of entries and if we add up everything, the sum will be 165. Now, there are some things we can observe from here, like the first term A, this is the very first term, is minus 3, so A is minus 3. And then the common difference is the difference between the subsequent terms and the initial term. Like in this case, it will be maybe minus 1 minus 3, or it can be 1 minus 1. Okay, in both cases you see that minus 1 minus 3, these two negative signs will multiply to become plus, so we have minus 1 plus 3, and that's going to be 2. Or in the second case, this same D, you can say is 1 minus 1. Minus multiply each other will give us plus, so 1 plus 1, that is 2. So the first term is minus 3, the common difference is 2, and then we are told that the sum up to a particular term, Sn, is 165. So what we're asked to find is to find the number of terms that we add up to this 165. Now the question is, what is the formula for evaluating the sum of some terms in an arithmetic progression? That sum, Sn, is giving us n over 2 multiplied by 2a plus n minus 1 multiplied by the common difference D. So this equation is what we can use to actually solve for n, because like here we're giving Sn, n is what we don't know, the number of terms, but the sum of that number of terms had been given as 165, so we have 165 is equal to n, which we are looking for, over 2 multiplied by 2a. A is minus 3, so we have 2 times minus 3, plus, again we don't know n, so we have n minus 1 multiplied by D. And what is our D? The common difference, that is 2. So we just need to open up this and solve appropriately. If 2 is multiplying 165, that will be 320, then 10, 330. So we have 330 is equal to n multiplied by 2 times minus 3 is minus 6, then plus 2 times n is 2n, minus 1 times 2 is minus 2. Okay, so here we can say we want to open that bracket, and we have 330 is equal to okay, we can still solve this. N multiplied by 2n, yeah, minus 6 and minus 2 we add up to be minus 8. So if we just move all of this to the only one side, I can have 2n times n will be 2n square. Okay, then n times minus 8 will be minus 8n. Okay, then 330, if it comes to this side, it will become minus 330, and the sum of all this will give us 0. Now, this is looking like a quadratic equation, but we can simplify further by dividing each of the entities by 2. So if I do that, I will have this to be this beautiful quadratic equation as n squared minus 4n minus 330 over 2. 23 is 1, 13 is 6, and 10 is 5. So this is a quadratic equation that we can solve with whatever method we find appealing to us. And here I want to look at 165n squared, and I want to look at, okay, minus 165n squared, and I want to look at minus 4n. So to solve this, I need to look for two terms that I can multiply to give minus 165n squared, and when I add them together, I will give us minus 4n. So if I'm looking at 165 as a number and I want to just find all the factors of that, I can divide. Okay, I think 3 can go. 3 in 16 is 5, remaining 1. 3 in 15 is 5, so 5 can go in 55, that is 11. 11 can go in 11, that is 1. So I'm having these entries. What I can do is I can try to look at the combination of this in whatever format that can be suitable. So if I take 3 and 5, the product of the two, that's 15. 15 and 11, I think this is giving us something worthwhile. Let me clear this board. So I can say I want to look at 15n and 11n. I know now if I'm taking the negative of one of them, then the product will give us a negative number. But looking at this sum, which one should we take the negative? I think it should be 15 that should take the negative, because minus 15n plus 11n will give me minus 4n. And if I say minus 15n times 11n, that will also give me minus 165n squared. So I'm on track, and I can say for this particular expression, I can write it out as, now I can say n square, but instead of writing minus 4n, I can just say minus 15n, okay, plus 11n minus 165 is equal to 0. You see, it's consistent because minus 15n plus 11n is actually minus 4n. So I can solve for that to say, in the first case, n is common to both. This will remain n minus 15, okay, then plus 11, and this will also remain n minus 15. This is equal to 0. So looking at that, I have two factors, n plus 11 multiplied by n minus 15 is equal to 0. So taking these two is either n plus 11 is 0 or n minus 15 is 0. And looking at this, in this case, n is equal to minus 11 and here n is equal to 15. But we are looking for the number of times, so definitely n is minus 11 cannot be the correct answer because it's negative. The number of times have to be an iterated value starting from 0. It cannot be negative, so our solution is that n is equal to 15. All right. In this question on trigonometry, we are told that if sine x is equal to p minus q over p plus q, where x is an acute angle, and that is why it is defined as being between 0 degrees and 90 degrees, we have to find 1 minus tan square x. So what we are going to do here is to ensure that we make use of the trigonometry identity SOHCAHTOA. So SOHCAHTOA is going to be quite useful for us, and here particularly we are making use of the sine and the tan. Now originally sine x, since we are talking about x, is opposite over the hypotenuse. As seen here, this is so opposite over hypotenuse, and from the question we are told that this is p minus q over p plus q. But that means that we know that if we are to define the triangle, we can find the three sides of the triangle from here. If we say this is angle x, then the side facing it is the opposite, and that was given as p minus q. The side facing the right angle, which is also the longest side, is p plus q as given. But for us to evaluate tan is opposite over adjacent, so we need to find the adjacent, okay? So if we call that adjacent m, then we can use the Pythagoras theorem to find the value of m. We want to use the Pythagoras theorem. That means that we can say that the square of the hypotenuse, which is let me just use red ink, which is p plus q raised to power 2, that's the square of the hypotenuse, is equal to the sum of the squares of the two other sides. So we have this will be p minus q raised to power 2 plus m raised to power 2. So if we make m the subject of the formula, we'll have m raised to power 2 is equal to p plus q raised to power 2 minus p minus q raised to power 2. Now we can say we want to start opening up this bracket and try to solve this particular expression for him, but there is the difference of two square equation that we know that if you have a square minus b square, this can be evaluated by saying this is the product of the sum of the two numbers and the difference between the two numbers. So this is what we are having as the difference of two squares. A square minus b square is equal to a plus b multiplied by a minus b. Okay, so if you want to use that here, p plus q will be synonymous to a, p minus q will be synonymous to b. So we can say in that case m square m raised to power 2 is going to be first p plus q plus p minus q, that's the sum of the two numbers, okay, then multiply by p plus q minus p minus q. So this is the difference between them. This is the sum of the two numbers, okay? So if you want to find this, we will say this is equal to, now let's be quite observant, p and p will be 2p, but look at this, this is q and this is minus q, so those we have known that. So we have, in the first case we have 2p, okay, then here in the second case we have p plus q minus p minus q. So this is going to be, here this p and this minus p will be out, but q minus minus q we turn to q plus q because the product of two negative signs is a positive sign. So it will be q plus q, and that will be 2q. So here we have 2q, such that our m square is 4pq. And if that's the case, then m will be the square root of 4pq, and the square root of 4pq we can say is square root of 4 is 2, and pq we still have in the square root. So that's what we are going to find as the adjacent for this particular triangle. However, what we're asked to find is 1 minus tan square x. So we can say tan x with all that we have been saying, which is opposite. Tan is opposite over adjacent. So this is opposite divided by the adjacent. Is going to give us, where is the opposite that we have? It is p minus q we have been given originally, okay, divided by what's the adjacent? 2 root pq. So for us to find 1 minus tan square x, 1 minus tan square x will be 1 minus p minus q over 2 root pq raised to power 2. So we can just say we want to express this. We can have this as 1 minus, we still have p minus q as the numerator raised to power 2. But here, the square of 2 root pq, if you look at, that is the m that we are coming from before. Okay, this is m, and m raised to power 2 is 4pq. So we have this as 4pq. And with this, you can say we want to find the LCM, and this will be 4pq minus p minus q raised to power 2. Okay, so we can open up that bracket to say we have 4pq, and here this is also 4pq, minus p minus q multiplied by p minus q. But now, let's just be careful with our sign, because this negative sign is going to affect the whole of this entry. So this will be 4pq that we have here, minus, now p multiplied by p is p square, p multiplied by minus q is minus pq, but we're also going to have another minus q multiplied by p, so we have minus 2pq, then minus q multiplied by minus q, the negative sign will multiply to become a positive sign, and then we have q square over 4pq. So our work is almost done, because here we can just see that this is going to give us 4pq minus the whole of this. If you are to open the bracket, we can say this is going to give us 4pq minus p square. This minus and this minus will multiply to give us plus 2pq, okay. Then this minus and this plus will be minus q square over 4pq. And now our final answer, after all has been said and done, we can see that 4pq and 2pq can add together to give us 6pq, okay. Then we have minus p square, then again minus q square divided by 4pq. So this is going to be the value of 1 minus tan square x as requested in the question. Here in this question, the resolution of forces, we are told that 3 forces, 10 newtons, 14 newtons, and 16 newtons, acting on a particle, keep it in equilibrium. So we need to note what that is going to mean for us. But our question is that we have to find the angle between the forces 10 newtons and 16 newtons. So we are to start just like the way they ordered it. We are to, now here, this is the 10 newton force, okay, and then incline at some angle to it is the 14 newton force. Then we have the 16 newton force, going to be a counter force that nullifies the effect of those two forces. Then we are going to have their direction like this. In the first case, this will be the 10 newton force. Here, this will be the 14 newton force. But in the opposite direction, now you can see this going like this in the positive direction, here in the positive direction. If we add that 16 upward, then it will have to act like this, and that resultant force will not be what we are looking for. We want it to cancel the resultant effect of the 10 newtons and the 14 newton force, so that will need to come like this. So this is actually going to be the 16 newton force, okay. So this is what we have, and to solve this particular one, we can make use of the parallelogram law of vectors to say we want to complete that diagram. And let me just show that quite faintly. And just say we want to complete this diagram by drawing something like this and then just completing it like that. You can see this is just already looking like a parallelogram. So we can say we want to find some angle, whatever angle we can find suitable. Maybe I think this is looking very good. We can find this as angle theta and we can try to solve for the theta. So we want to look at the effect of the forces at a point. So if you say this is the particular point that we want to find the emanation of each of those forces, we can say the 10 Newton force is acting in this direction, which is quite consistent with what we have initially. But the 16 Newton force we need to actually pull like this in the other direction. So what we have inherently is that this is the 16 Newton force and here this is the 10 Newton force. So this particular location here, this region here, is going to be the angle between the 16 Newton and the 10 Newton force. And if that is the case, this angle that we are looking at is not going to be accurate. It is obtuse. It has to be greater than 90 degrees because by solving this particular question, we are going to get theta, but that theta is not going to give us our answer. So from here, it's as if we are moving the point of action of the force to this particular location such that the 10 Newton force is acting here. So that you just need to understand this to be able to get this question effectively. So it's as if we are having this as the 10 Newton force. You can see I just knew it. But then emanating from that same point as the 10 Newton force is the 16 Newton force. And the angle that we are interested in is going to be this particular angle here, which we can see from the diagram that angle alpha, okay, this alpha here, we can see from this diagram that theta plus alpha is equal to be 180 degrees. Why am I saying that? Because they are the angles that are included in a transversal and two parallel lines. We are going to see the parallel lines here now. So here, it is the 10 Newtons. This 10 Newtons is parallel to this particular 10 Newtons that I have here. And you can see the question that we are asked to find is to find the angle between the 16 Newton force and the 10 Newton force. So it's going to be this angle here, and that will be the correct solution to our question. And in that case, if you are to do that, that means that here we can just say our alpha that we are looking for is going to be 180 degrees minus the value of theta. Okay, so the question before us first and foremost is to find the angle theta. And looking at this particular diagram, you know this is looking like a triangle in which we know one of the sides, we know the three sides and one of the angles, and with that we can use the cosine rule. So using cosine rule can effectively help us to solve for this particular unknown angle. And we can just say here 14 is the side that is facing that angle. So the square of 14 is equal to the sum of the square of the other two sides, 16 square plus 10 square minus 2 multiplied by 16 multiplied by 10 cos that angle that we are looking for, which is theta. Okay, so if we just rearrange this and bring the whole of this cosine to the left hand side, we can have it at 2 times 16 is, okay, let me just write that 2 times 16 multiplied by 10 cos theta is equal to, on the right hand side now we have 16 square plus 10 square minus 14 square. Okay, so 2 times 16 is 32, 32 times 10 is 320, so we have 320 cos theta is equal to 16 square plus 10 square minus 14 square. Let's just use our calculator for that. So we are going to have 16 raised to power 2 plus 10 raised to power 2 minus 14 raised to power 2. That is 160. This is 160, and I can just divide both sides by 320. So here this 320 will cut this 320. 160 here 1, 160 here 2. So cos theta is 1 over 2, which is 0.5, and in that case theta will be arc cos 1 over 2, and arc cos 1 over 2 is 60 degrees. So we have gotten theta to be 60 degrees, but nobody asks us to find theta. So note where the angle is not just at 60 degrees, just like I explained before. The angle is actually the angle alpha, and from the foregoing we have said that alpha is defined as 180 minus theta, and theta we have obtained to be 60 degrees. So alpha is 180 minus 60, which is 120 degrees. So 120 degrees is the value of the angle between the 16 Newton force and the 10 Newton force. Just look at it that at the point where the forces are acting, they need to pull in two different directions, and that is how we can find the angle to be obtuse and not acute. All right. In this question on moment of forces, we are told that a uniform beam WX of length 90 centimeters and weight 50 newtons is suspended on a pivot, which is 35 centimeters from W. Now, the beam is kept in equilibrium by means of forces T and 20 newtons applied at Y and Z respectively. WY is 10 centimeters and SZ is 10 centimeters, and we are asked to find the value of T. So to go ahead trying to solve this question, we can as well just try and draw the particular beam that we are being told here. The fact that it is uniform means that it's going to be evenly distributed, okay? So if you have something like this, we can say the weight, which is the 50 newtons, will be acting at the middle of the beam. So we are told it is 90 centimeters, and the weight we just need to act down here. So this is 50 newtons, and that 50 newtons is going to be acting at the midpoint of the uniform beam, okay? Because it's uniform, this will act at the midpoint. And now we're told that the length is 90 centimeters, so the midpoint will be 45 centimeters. Let's just note that. So we're now told that it is being suspended on a pivot, which is 35 centimeters from W. So if we take this as the point W, and we'll take this as the point X. Now, 35 centimeters from W, since the weight is at the middle from here to here, that will be half of 90 centimeters. So it will be 45 centimeters, which is half of the length of the beam, okay? Then we are told that from 35 centimeters from W, so maybe somewhere like here, we have the support on a pivot. Can have a pivot here. Okay, so that pivot is 35 centimeters from W. So the distance from here to here, that will be 35 centimeters. Okay, so it is kept in equilibrium by means of forces T and 20 newtons applied at Y and Z respectively. Okay, so what is the position for Y? We are told that WY is 10 centimeters, so W to Y will be 10 centimeters, and at that point we have a force which is, so down here we have a force T that is 10 centimeters from W. So this point is point Y, and it is 10 centimeters from W. Between W and Y is 10 centimeters, and then XZ from the other end X to another point here, we have another force which was given as 20 newtons, and this is also 10 centimeters. Okay, from the 20 newton force to X, so this is point Z. Okay, and we are now being asked to find the value of T. T is what we are looking for, so we can do well to finish up our diagram, because if you look at this, to find T, we can just take moment about one of the pivots. Okay, so taking moment, we take the moment about the pivot, shade that in blue. Okay, so we will try and evaluate the distance of each of the forces to this particular pivot. Now look at this, we have seen that from W to the pivot is 35 centimeters, from W to T is 10 centimeters, so the remaining here will be 35 minus 10. So this place here is going to be 25 centimeters. So I can just append that this is 25 centimeters from this force to the pivot. Okay, then from the center of the uniform beam to this pivot, already from W to the center is 45 centimeters. Now we have taken 10 and 25, which is 35 centimeters out, so the remaining here is also 10 centimeters. Okay, all right, good. So now we also have this force, the 20 Newton force here, and we are told that it is 10 centimeters from X. The whole of the length is actually 90 centimeters as given in the question. If we take 10 centimeters out, then this remainder from W down to here should be 80, or better still, we can say since half of that length is 45 centimeters, we're taking 10 centimeters out. So from here to Z, from the midpoint to Z will be 35 centimeters. Okay, so 35 plus 10, that is 45 on this right hand side. But we are looking at the distance from this 20 Newton force to the pivot, and that will be 35 plus this particular 10 that we have. So from here, this will be 45 centimeters. So those are the parameters that we'll be needing to actually evaluate this particular question here. And if we take moment about the pivot, this is our point of interest now. I want to take the moment about the sum of the clockwise moments is equal to the sum of the counterclockwise moment. So that's what we are going to be using here. And if we look at that, taking this pivot, this particular force T will have a moment that is tending towards this side. Okay, but for the 50 Newton, which is the weight of the uniform beam, it will be going like this, which is clockwise. Okay, T will be counterclockwise, but the weight of the uniform beam will be clockwise. So we have this here to be clockwise, we have this to be counterclockwise, and for the 15 Newton we also have this to be clockwise. So the sum of the moment in the clockwise direction is equal to the sum of the moment in the counterclockwise direction. So in the clockwise direction we have 50 newtons multiplied by the distance, okay, because it is the product of the force and the perpendicular distance. And you can see the force is acting downwards, the distance is acting horizontally, the force is acting vertically, so that is perpendicular to one another. So 50 multiplied by the distance from the midpoint of the uniform beam to the pivot, that will be 50 multiplied by 10 centimeters. Okay, this is the first clockwise, plus the second clockwise, that will be 20 multiplied by the distance from this 20 Newton force to the pivot, which we have gotten to be 45 centimeters. Okay, is equal to, now this is the clockwise, the counterclockwise will now be the product of the force T and its distance to the pivot, which is 25 centimeters, so is equal to T multiplied by 25. All right, so we can just say from here 25T is equal to 50 times 10 is 500 plus 20 times 45, that will be 2045 is 90, then with that 0, 100. So 25T is equal to 500 plus 900, that is 1400, such that the force T will be 1400 divided by 25. Okay, so 1400 divided by 25 is going to give 56 newtons. So T is nothing but 56 newtons, and we have been able to get that because we are able to interpret our question appropriately and find the distance from each of the active points to the pivot, and then we take moment about the pivot and we're able to get the value of force T to be 56 newtons. In this question of statistics, we are told that the table shows the age distribution in years of a group of people. So we have that table here, age in years and the number of people. Okay, so we are to use an assumed mean of 13 years to find the mean age of the people. So the very first thing we need to understand is how do we use the assumed mean to evaluate the mean of a set of given data like this. So we are going to be generating a particular table, but that mean for this type of question is giving us the mean x is equal to the assumed mean plus the summation of the product of the frequency and the deviation over the summation of the frequency. So we are going to find the deviation interpolated on our table as is going to be shown now. Now, the age in years, so this is the column for the age. Here we are going to have the class mark, which I'm going to call x. Now, x is going to be the midpoint of that particular set of data that we are looking at. Like in the first case, when we have the age is 1 to 5, x will be the midpoint of this particular data set. And we can get it by saying the lower limit, which is 1, plus the upper limit, which is 5, divided by 2. So that is going to give us 6/2, which is 3. Okay, and we can do that for each of the entries of those age brackets. So it's just the midpoint, and this is also a means of finding the midpoint of that particular data set. So let's just keep that in mind as we go ahead trying to solve our question. So that's how we get the value of the class mark. Okay, then we can input the frequency, which is going to be the number of people in this particular question. Then we can find the deviation, which is defined as the difference between the class mark and the assumed mean. So it is the class mark that we got here in this column, this second column. We are going to subtract the assumed mean that we are given as 13 years from that mark to get the deviation. Okay, then we can also find the product of the frequency and the deviation. So this is what we need, and in populating this, we know we have 6 to 10, then 11 to 15, then 16 to 20, then 21 to 25, and finally we have 26 to 30. So for this particular case, I exemplify that the class mark, which is the midpoint, is going to be 3. For this, 6 plus 10 is 16, 16/2, that is 8. Here, 11 plus 15 is 26, 26/2 is 13, and in short, it's going to be a consistent incremental value of 5, like 3 plus 5 is 8, 8 plus 5 is 13, 13 plus 5 is 18, 18 plus 5 is 23, then 3 plus 5 is 28. You can also check by looking at the midpoint of this data set, and you will see that it is consistent with what we have got. Now, the number of people is the frequency. In the first case, we have 18, then 12, then 25. Just inputting these values directly here. Then we have 15, we have 20, and we have 10. Okay, so we can sum all of this so that we can have 18 plus 12, that is 30, 30, okay, 25 and 15, that is 40, plus 30, that is 70, plus 20, that is 90, plus 10, that is 100. So summation F is 100, because we are going to make use of that. So to get our deviation, it is the class mark, this column, minus the assumed mean that we are giving us 13 years. So that's what we are going to be doing. Students, don't make the mistake of using frequency to subtract. Okay, it is the class mark x. So 3 minus 13, that will be minus 10. Okay, 8 minus 13, that will be minus 5. 13 minus 13 is 0. 18 minus 13 is 5. 23 minus 13 is 10. And 28 minus 13 is 15. You can also see that there is a consistency to this particular value. Now we want to find the product of the frequency and the deviation in this column. 18 times minus 10 is minus 180. 12 times minus 5 is minus 60. 25 times 0 is 0. 15 times 5, that is 75. 20 times 10, that is 200. And 10 times 15, that is 150. So we can also find the summation FD. Here, summation FD. And let's just make use of our calculator. We say we have minus 180 minus 60 plus 0 plus 75 plus 5 plus 200 plus 150. What's that? That is 185. So this is 185, and meaning that if we cannot bring this particular set of values that we have into our equation, the mean will be the assumed mean, which is 13, plus the summation of FD, that is 185, over summation F, that is 100. So this is going to give us 13 plus 185 over 100 is 1.85. So the mean for this particular set of data is 13 plus 1.85, which is 14.85 years. So that is going to be the way that you evaluate the mean of a set of values given the assumed mean as given in this particular question. All right. In this question on probability, we are told that two fair dice are thrown together 2 times. We are to find the probability of obtaining a sum of 7 in the first row and a sum of 4 in the second row. So to solve this question, we will need to bring in our truth table. And here, this is our truth table. Our operation is sum. So we are going to be summing the entries for both set of dice. And now, in the first case, the first die can show any of 6 possible entries. Okay, those are the numbers that are on the face of the dice. So you can have 1, 2, 3, 4, 5, or 6. Okay, and in the second case, the same thing will also happen. We can have any of 1, 2, 3, 4, 5, or 6 as a number to display on the dice when it is thrown. Now, we are looking for a sum of 7 or a sum of 4. So in both cases, we are looking at sum. Summation is what we are looking at, so that's how we can sum. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. So we can just sum all like that. So having populated all of this, we can see that this is very consistent with what we're looking for. Like when you have 2 6, this is 1 6, this is another 6, then the sum will be 12. If you have 4 and 5, this is 4, and then 5, then the summation will be 9. Okay, so that's good, that's wonderful. What we're asked to find is the probability of obtaining a sum of 7 in the first row. So where are we going to have the possibility of having 7? Here, look at this. If you look at this entry, you can see that that's where we have the sum to be 7. So we should know that. And then in the second case, we are told that the sum will have to be 4 in the second row. So for 4, here we have this for 4. Okay, so now having gotten that, we can say the probability of obtaining a sum of 7 is going to be the number of entries of the addition that is giving us 7. In this case, 1, 2, 3, 4, 5, 6 over the total number of possible outcomes, which is 6 times 36, because that's the definition for probability, is the total number of desired outcome over the total number of possible outcomes. Here we have it as 6 over 36, and we can actually cut 6 here 1, 6 in 36, that is 6. So this is 1 over 6. But that's not all. We're also looking at the probability of obtaining a sum of 4. That's in the second row, and you can see the desired outcome for 4 only occurred 3 times. So we have 1, 2, 3. So that will be 3 over the total number of possible outcomes, which is 36. And again, we can cut 3 here 1, 3 in 36 is 12. So this is 1 over 12. But nobody asked us to do that. We are originally asked to find the probability of obtaining a sum of 7 in the first row and the sum of 4 in the second row. And is the word that we need to take note, because in probability, when we see that, that means we multiply. So the probability of obtaining sum of 7 and in the first row and the sum of 4 in the second row is going to be the product of these two. So it's going to be the probability of sum of 7 multiplied by the probability of the sum of 4. Okay, so that will give us 1 over 6 multiplied by 1 over 12, and the numerator will still be 1 multiplied by 1 is 1, 6 multiplied by 12 is 72. So 1 over 72 is the answer to this question as we're asked to solve it. In this question, the equation of a line and the curve, we are told that the curve y is equal to 7 minus 6 over x, and the line y plus 2x minus 3 is equal to 0. Two of them, they intersect at 2 points. Then we are to find first the coordinate of the 2 points and the equation of the perpendicular bisector of the line joining the 2 points. So now we can go ahead to say we want to solve this question, and in the first case, what we're having is that we have to find the coordinate of the 2 points. Now look at this equation. If I say I'm giving the y for the curve, okay, the y for the curve is given as x minus 6 over x, but then for the line, I was told that y plus 2x minus 3 is equal to 0. If I rearrange this, I'm going to have the y is equal to minus 2x when 2x moves to this side, then plus 3. And this is the y for the line, okay, for the line and the curve as given. But when we are told that they intersect at 2 points, that means that what we are looking at is the y curve is equal to the y line. At the point of intersection, this is what is taking place. The curve is equal to the line, okay. So at that particular point, we can equate these two equations to say we have 7 minus 6 over x is equal to minus 2x plus 3. So we need to actually try and find the solution to this x. On the left hand side, we can take the denominator to say this is going to now give us 7x minus 6, because x being divided by 1 is x, and x times 7 is 7x, and this is just as it is, then is equal to minus 2x plus 3, as if we are having this over 1. So having this expression, and we can cross multiply, and by the time we cross multiply, we'll have on the left hand side 7x minus 6 is equal to x multiplied by minus 2x is minus 2x squared, okay. X multiplied by 3 is 3x. So once we are able to get to this point, we can just rearrange because it's looking like quadratic equation already. So if I bring all of this on the left hand side to the right hand side, so if I bring all of this on the right hand side to the left hand side, I will have it be 2x squared, okay, then minus 3x, then plus 7x minus 6 is equal to 0. I can simplify further to say this is going to give me 2x squared minus 3x plus 7x is plus 4x minus 6 is equal to 0. I can see 2 is common to this term, so if I divide each of those entries by 2, okay, then here the 2 will cut out and I will have 1 remaining. 2 in 4 is 2, 2 in 6 is 3. So the new quadratic equation I can work with is x squared plus 2x minus 3 is equal to 0. So to solve this, I'm looking for a product that will amount to minus 3 and x squared. So minus 3x squared is the product, and then the sum is 2x. What two number can I multiply together to give me minus 3x and add together to give me 2x? If I look at minus 3x and x itself, I will see that minus 3x times x will be minus 3x squared. Good. But if I sum them, it will be minus 2x. So the negative sign is not supposed to be on the 3x. It should be on the x. So it will be 3x and minus x, because the product will be minus 3x squared and the sum will be 3x minus x, because it will be 3x plus minus x, and that is 2x. Here the product is minus 3x squared. So these two terms, 3x and minus x, is what I will use to substitute for 2x, which is the second term of the quadratic equation, and I will have it as x squared plus 3x minus x minus 3 is equal to 0. I can factor out x from the first two entries because I'm seeing it is common to both. So here will remain x, then here you have plus 3, and here I can factor out minus 1. Look at this, we have minus x minus 3. So I can bring minus 1 half, and it will remain x plus 3, not x minus 3, please, because minus 1 times x is minus x, and minus 1 times plus 3 is minus 3. If this is minus 3, it would have been minus 1 times minus 3, and that would have been plus 3. So the correct expression is minus 1 into bracket x plus 3 is equal to 0. So looking here again, I can factor out x plus 3 out because it's common to those two entries. Then x plus 3 here, taking out, it will remain x, and here taking out, it will remain minus 1. So this is equal to 0, meaning that x plus 3 is 0 or x minus 1 is 0. For the first case, x will be minus 3, and in the second case, x will be 1. So that is not all to our question, okay? That's not all to our question. We are only able to get the coordinate for x. We also need to find the coordinate for y. So we need to input into any of these equations so that we can get that appropriately. Let me just clear some portion of my board. So here now we can say when x is minus 3, we can take any of these two equations, okay? I can say y, okay, let me say I want to use the y for the curve. It's going to be 7 minus 6 over minus 3, okay? So these two negative signs will multiply each other and they will become plus 3 here 1, 3 here 2. Okay, so that will be 7 plus 2. So that means y is going to be 9, okay? That's in the first case. And in the second case, let me now use the linear equation. When x is 1, okay, y using the y line is going to be minus 2 times 1 plus 3, okay? Now, minus 2 times 1 is minus 2. Minus 2 plus 3 is 1. So the coordinates of the point which we were originally asked to find, the coordinates, please students, you need to understand what you are asked to do. In the first case, x is minus 3 and y is 9. So we have minus 3, 9, okay? X is minus 3 here and y is 9, okay? And in the second case, x is 1, and y is also 1, okay? That's interesting. So these are the coordinates that are the point of intersection of the two equations, the one for the curve and the one for the line. So these are the intersection points. All right. So that is good. So now to answer the second question, we have gotten our coordinates to be minus 3, 9 and 1, 1. So if we tag this as, let's say this is point A and this is point B, okay? We are now asked to find the equation of the perpendicular bisector of the line joining these 2 points. If we are to just consider a simplified look at the Cartesian coordinates, just something like this. Let's just have just a small pictorial view. So here we have minus 3 and 9 and then 1 and 1. So this point and this point, okay? So this is say 9, this is minus 3, this is 1, and this is 1, okay? So what we have is a straight line joining these 2 points, in which this is point A, that is 3, 9, and here this is point B, okay? What we are now asked to find is the equation of the perpendicular bisector of the line joining those 2 points. That equation is going to be something that is defining the perpendicular bisector of this particular line, okay? So for that particular bisector, we are going to know that it is inclined at angle 90 degrees to this. Now, from point A and B, we can say we want to evaluate the equation of the line AB, in which we have the coordinates of A and the coordinates of B. And then we know that for these 2 equations, if this one is carrying the slope m1, and the perpendicular bisector is carrying the slope m2. By reason of the geometry of straight lines, m1 multiplied by m2 is given as their product is -1. Okay, so once we can find the product of, when we can find the slope or the gradient of this particular line in which we have two coordinates a and b, then we can use this gradient to evaluate the equation of the second line in which the slope is going to be m2. So how do we find the equation of a line given these 2 points like this? We can say we want to look at the equation y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. Just maintain a consistency, and here for the first case this will be x1, this will be y1, okay, and this will be x2 and this will be y2. So we have to bring in those equations. We can say y minus y1, y1 is 9, so we have y minus 9 over y2 minus y1, y2 is 1 minus y1, that is 9, is equal to x minus x1. So we have x minus, what's the value for x1 is -3. Don't make a mistake of saying it is 3 over x2. x2 is 1 minus x1, that is -3. So this we can just simplify to say y minus 9 in the first case, okay, over 1 minus 9 is -8 is equal to x minus -3 will become x plus 3, and then 1 minus -3 will become 1 plus 3, and 1 plus 3 is 4. I can just cut. This is becoming interesting now. 4 here 1, 4 here -2. So I can now cross multiply to say I have it as y minus 9 is equal to -2 times x is -2x, and -2 times 3 will be -6, so that y will be -2x minus 6 but plus 9, and that will be y is equal to -2x plus 3. Okay, I love this. It's also in consistency with the graph that we just quickly sketch. You know, it's not really to scale, but even though it's not to scale, we can see that this is looking like the point 3 on the graph, which is the intercept, and then the slope is negative of 2, which is -2. So this slope here is -2. But having this as equation of the line joining the point A and B, that's not what we're asked to find. We're asked to find the equation of the perpendicular bisector. So, but from here we can see that since our y is obtained to be -2x plus 3, then comparing with y is equal to mx plus c, this is why I was noting that c, the intercept is 3 already. We can see that this implies that the m, which is m1, the one for this line, is -2, okay, and if that is the case, then m2 will be -1 over -2, because from here we can see that m2 is going to be -1 over m1. So -1 over -2, the negative sign will cancel out, so m2 is 1 over 2. Good, I love this. Okay, so we've been able to find the equation of the line joining AB, okay, then we've been able to find the slope to be -2. We've also been able to find the gradient of the perpendicular bisector to be 1 over 2. So what is left for us to now do is to get the equation of that perpendicular bisector. So we need to just do that. I will just clear this right hand board. So now I want us to notice something. This question is becoming interesting. At this particular point where the perpendicular bisector is going to touch this other line, this is going to be the midpoint of the line AB. Okay, so we know a point, the point, if I call this point C, so that point C is the midpoint of the line AB. So wow, this is interesting. So C is the midpoint of the line AB, And for us to get its coordinate, the coordinate of C is going to give us the half of the sum of x1 and x2, okay, comma y1 and y2, okay, and you will see how that will play out. So that's going to give me half of x1 is what? -3, and x2 is 1, okay, comma y1 is 9 and y2 is 1. So this is going to be half of -3 plus 1 is -2, 9 plus 1 is 10. So this is the coordinate of C, which is x comma y, is going to be half of -2, that is -1, comma half of 10, that is 5. So you can see that that's still a bit consistent with what we have here. Like here can be actually -5, and here you can see that it's actually something like -1. Okay, here can be 5, here can be -1, but no problem with that. It's just an indication that we are on point. So we have this particular point defined for our C, which is the midpoint of line AB, and we have the slope to be 1/2. So we can easily get the equation of the line, that is the perpendicular bisector of the line joining those 2 points, to be that we can have it that it will be y minus y1 is equal to m into x minus x1. Okay, so y minus y1 will be y minus, what's the y1 for C now? That is 5, okay, is equal to m, what is our m, is 1/2, multiplied by x minus, what's the x1 is -1. Okay, so here we can just say we have it that these two can just cross multiply to the other side to have, we have 2y, okay, minus 10 is equal to x minus -1 will become x plus 1. So if -10 is to go to the other side, we just have it as 2y is equal to x plus 1. Then when 10 moves to the other side, it becomes plus 11. And so this is the equation of the perpendicular bisector of the line joining the 2 points A and B as requested in the diagram. And if you want to see that the slope is 1/2, just divide both sides by 2. Okay, so y will be standing alone here, and then of course the coefficient of x will now be 1/2, and then the intercept will be 11/2, which will be like 5.5. So it's not too reflecting here, but we just get the general idea of what we are trying to depict, and the solution to our question is now done and dusted. We've been able to find the coordinate of the 2 points by equating the curve and the line to get the point A as -3,9 and B as 1,1. And then we went ahead to find the equation of the perpendicular bisector of the line joining the 2 points by first evaluating the slope and then looking at the midpoint of the line AB to get C. And of course, after getting that, we can put into the equation for a straight line to get it as 2y is equal to x plus 11. In this question on quadratic equations, we are told to find the range of values of p for which 4x squared minus px plus 1 is equal to 0. This equation for which it has real roots. So we need to understand what are the conditions for real root. So looking at this question, the condition for real root is that for equation as squared plus bx plus c as a quadratic equation, for real root, we need to be able to evaluate that b squared minus 4ac is greater than or equal to 0 for real root. So if we are to take this as a guide, and we will consider our equation here, which was given as 4s squared minus px plus 1 is equal to 0. If we compare it to, just compare this to as squared plus bx plus c is equal to 0, we can see that readily a is 4, okay, by comparing the two, b is minus p, okay, and c is 1. So if you are to use 4 as a, minus p as b, and 1 for c, in this particular condition for real root, we are going to have it that in that case b squared will be minus p raised to power 2, okay, minus 4 times A our A is 4, times C, our C is 1, okay? This ought to be greater than or equal to 0. So minus P square is going to give us P square. 4 times 4 is 16, 16 times 1 is 16, is greater than or equal to 0. But this I can express as P square minus 4 raised to power 2, which is greater than or equal to 0. I did it because I can easily try and solve this as a difference of two squares. Instead of saying I move minus 16 to the right hand side, then find the square root of both sides, then plus or minus 4. Let me just do this because this is a bit more seen. So I can say this is now P plus 4 multiplied by P minus 4 is greater than or equal to 0. In this case, that means that P plus 4 is greater than or equal to 0, or P minus 4 is greater than or equal to 0. So for the first case, P will be greater than or equal to minus 4, and on the second case, P will be greater than or equal to 0. Now, students, you don't just leave your answer like this and say, yes, I have done the work and through with it, I blasted it. No, let's test for this particular value, okay? Like on this note, if you want to look at the number line when you are working with inequalities, these are the rule of thumbs that you need to follow, okay? So you look at the number line in which you have the positive and the negative as this. Let's say we have the origin 0. Okay, let's say we have this to be minus 4. We have this to be 4. Let's say this is like, it's not linear, so you can just call this 5, and this is minus 5. Now, looking at the graph that we have, looking at the solution that we have profiled, you can see that we say P is greater than or equal to minus 4. Because of the or equal to, I'm going to make this a solid line, okay? And then P greater than this minus 4 means that P is moving in this direction, okay? Then P, this is not 0, this is 4. That's going to be quite a costly mistake. Not 0, it is P is greater than or equal to 4, okay? So here, for this particular case, okay, in this case, it is that P is greater than or equal to minus 4, so it's moving towards this side. In this case also, it is that P is greater than or equal to 4, so it's also moving towards this particular side. We need to check where is the range in which we are going to have our correct value. Is it going to be here in this particular region, or is it going to be here, between here, or is it going to be here in this particular region? So I'm going to test for each of the values. I'm going to take minus 5, okay? I will take minus 5, I will take 0, and I will take 5 as the values with which I want to test, okay? I will take minus 5, 0, and I will also take 5 for each of those regions to see where this particular equation is going to be real. For example, look at this. When P is minus 5, that is, it is actually to this side, then our equation, the quadratic, is going to give me 4x squared minus P is now minus 5, okay, multiplied by x plus 1 is equal to 0. And here we can see that the equation will become 4x squared plus 5x plus 1 is equal to 0. Now we want to test with b squared minus 4ac. In this case, b squared minus 4ac is going to be, what's my b? B is 5, so 5 raised to the power 2 is 25, minus 4 multiplied by a, which is 4, multiplied by c, which is 1. So this is 25 minus 16. So I can just say it's 25 minus 4 times 4 times 1 is 16. So this is 9. Here is 9. And that particular 9, of course, is greater than, but let me just put or equal to, but I know it's greater than 0. So this condition is looking quite okay. But don't worry, let's look at another condition. When P is equal to, let's say 0, then in that particular case, we'll have it that 4x squared minus P is now 0, 0x plus 1 is 0. So for that particular case, we just have it as 4x squared plus 1 is equal to 0. And if you are to test for b squared minus 4ac, that will be b is 0, okay? Minus 4ac will be minus 4 times 4 times 1, and this is going to be minus 16. Of course, minus 16 is not satisfying this condition, is not greater than 0. Okay, so definitely this is not a point for us to consider. And on the third case, when p is, let's say it is equal to 5, so we'll have our equation to be 4x squared, okay, minus p is now 5, okay, of x plus 1 is equal to 0, and then that will simplify to be 4x squared minus 5x plus 1 is 0. So in this case, b squared minus 4ac will be, b is now minus 5. Minus 5 raised to power 2 is 25. Okay, then minus 4 times 4 times 1 is 16, and this is also 9. So this is also satisfying the equation. So we have only two conditions, here and here, and those range is corresponding to, look at this, to p is less than or equal to minus 4 and p is greater than or equal to 4. It is this region here. Okay, I will just recollect what I had initially so that students, you get this right. So the point that satisfy the particular condition we are looking for is not the one that we just saw. We need to test actually when we are working with inequality. So that point that satisfies the equation is going to be here and here. Okay, it is this side, and that is giving us p is less than or equal to minus 4, and here p is greater than or equal to 4. How did I get that? I got that by testing for the values that I got to ensure that they conform to the condition for real root, which is b squared minus 4ac is greater than or equal to 0. So this is the way you go about trying to solve questions, ensuring that you work only through your question. You don't just leave halfway. You don't just get some values and you think that yes, I've blasted. No, you need to test and eventually get the totality of your question. And with this, you've been able to finish this question as appropriate. In this question on binomial expansion, we are told that first we should expand 1 plus 3x all raised to power 6 in ascending powers of x, and then using our expansion in 1 above, we are to find correct to first significant figures the value of 1.03 raised to power 6. Okay, good and wonderful. Now, to evaluate this in ascending powers of x, there is actually the binomial formula that we have, but as a rule of thumb, I generally will advise students to make use of the Pascal's triangle, in which we have for expression in which we have a plus b hypothetically raised to power 1, then we are just having the coefficient as 1. But when we have a plus b raised to power 2, we have 1, 2, 1 as the coefficient of the factors. So a square, we have 1 as its coefficient, ab will have 2 as its coefficient, and b square we have 1 as its coefficient. So just on and on like that, we are going to have 1, 3, 3, 1, in which we are just adding these two numbers. 1 will always begin, 1 will always end, but you add the internal numbers. So 1 plus 2 is 3, 2 plus 1 is 3. In this next case, we have 1 to start. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1 will end. Okay, so next one we have 1, 4 plus 1 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1 will also end. Okay, and in the next one we have 1 to start. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and we have 1 to also be ending. Then this is actually, I want to clear this. So this is to the power of 2, this is to the power of 3, this is to the power of 4, this is to the power of 5, and this, as in the case in which we are trying to work, is to the power of 6. All right, so this is the Pascal's triangle that we can make use of to say we want to expand 1 plus 3x all raised to power 6. So this is synonymous to the a plus b raised to power n that we are looking at initially. But for this particular one, we can actually expand it to say we have 1 plus 3x raised to power 6 will be, in the first case, 6 combination 0, okay, then 1 raised to power 6 multiplied by 3x raised to power 0. I will come to explain this later. Plus 6 combination 1 multiplied by 1 raised to power 5, then 3x raised to power 1, plus 6 combination 2 multiplied by 1 raised to power 4, then 3x raised to power 2, plus 6 combination 3, 1 raised to power 3 multiplied by 3x raised to power 3, plus 6 combination 4, 1 raised to power 2 multiplied by 3x raised to power 4, plus 6 combination 5, 1 raised to power 1 multiplied by 3x raised to power 5. Okay, let me just squeeze that in. Okay, then finally plus 6 combination 6 multiplied by 1 raised to power 0, 3x raised to power 6. Okay, so this is what I was doing originally. This is it. Now, so 6 combination 0 and 6 combination 6, they are both 1. So they are going to take these extreme values 1 and 1. Okay, 6 combination 1 is 6, 6 combination 2 is 15, 6 combination 3 is 20, 6 combination 4 is 15, 6 combination 5 is 6, 6 combination 6 is 1. Okay, so that's them. But for the entries, you can see in the first entry, 1 started with the highest power, which is 6, and then it is reducing sequentially. You can see 6, 5, 4, 3, 2, 1, and 0. Okay, so those are the way that we deal with the power of the first entity, and then the second entity will start from 0. So here you have 0, 1, 2, 3 as the power of 3x, 4, 5, and 6. Okay, so those are symmetries you want to watch out for. Then in addition, the addition of the power per entity per term is going to add up to 6. So you have 6 plus 0 is 6, 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6, 1 plus 5 is 6, and 0 plus 6 is 6. So if you want to really expand this out now, we can say this is going to give us, now for these combinations, this is what I've used the Pascal's triangle to evaluate out. So I have, in the first case, this is 1. 1 times 1 is 1. 3x raised to power 0 is also 1. So 1 is the only entity that we have here. Plus, in the second case, 6 combination 1 is 6. 1, in short, in all the places where we have 1 raised to power any number is 1. So we don't need that. But here we have 3x. So 6 times 3x is what we can evaluate here. Okay. Then plus, in the second case, 6 combination 2 is 15. Then we have 3x raised to power 2. 3 raised to power 2 is 9. So we have this as 9x squared. Okay, so I open the bracket for the number, but the variable is still retaining the power. Then plus 6 combination 3 is going to give me 20, which I've already evaluated with the Pascal's triangle as a guide. Then 3 raised to power 3 is 27. So I have this as 27 multiplied by x raised to power 3. Okay, then plus 6 combination 4 is 15, which Pascal's triangle is helping us to solve out. Then 3x raised to power 4. 3 raised to power 4 is 81. So this is times 81 multiplied by x raised to power 4. Okay, plus 6 combination 5 is 6. Then 3x raised to power 5. 81 times 3 is 243. So this is 243 multiplied by x raised to power 5. Okay, then finally I'm going to have 6 combination 6 is 1. Then 3 raised to power 6. I think I will make use of the calculator there. 3 raised to power 6 is equal to 729. So this will be 729 multiplied by x raised to power 6. Okay, so we just need to now find out the product of all of this. So this will be 1 plus 6 times 3 is 18x. Okay, 15 times 9 15 times 9, that's 135. So we have plus 135 s squared, okay? Then here plus, so 15 times 81, you can say 15 times 81 is equal to what? 1215. So here we have it as, this is 1215 x raised to the power 4, then plus this next entry, 243 times 6, 243 times 6, that is 1458 plus 1458 x raised to the power 5, and finally plus 729 x raised to the power 6. So this is the way to go about evaluating this value out. So we've been able to get that what we just wrote out, this long equation, is 1 plus 3x raised to the power 6. So this is the very first question that we're asked to find. You can see how we use the Pascal's triangle, or you can go ahead and just use the combination formula, whether by your calculator or you want to work it out, to express this equation out. All right. Now, in the next question, we are told to use the expansion that we got here to find correct or false significant figures, the value of 1.03 raised to the power 6. We are going to be doing that right about now. We can notice that this is the question 1. So we are going to question 2 now. So now, from the previous question, we've been able to expand 1 plus 3x raised to the power 6 as this binomial expression. But now we are being told in this second question that we are to find correct or false significant figures, the value of 1.03 raised to the power 6. Now, if you are to comparing, let's just do this. If we compare, now if you are to compare 1 plus 3x raised to the power 6 and 1.03 raised to the power 6, we can see that, 1 is common here. We can see that 1 can actually be taken out so that we can have it as, let's say we have, I'll just write this as equality. So I can have 1 plus 3x is equal to 1 plus 0.03, okay? Because this one is standalone, so if I make this to be standalone, then I can knock out this 1 and I can say, therefore, 3x is equal to 0.03, and if I divide both sides by 3, then I can find my x to be, x is equal to, look at this please, 3 can cut here 3, 3 here 1, 3 here to be 0.01. So the value of x is actually 0.01. So I've been able to compare the original expansion that we carried out with the new solution that we're asked to find, and I've gotten the value of x to be 0.01. Students, you may just want to say here x is 0.3, then you are going to miss it because already we have a factor, a coefficient in front of x. So you need to take that out to get the original value of x as 0.01. So the binomial expansion therefore will not be that 1.03 raised to the power 6 will be in this expression. Anywhere you find x, you don't use x now, you now use 0.01. So that will be 1 plus 18 times 0.01, okay, plus 135 times 0.01 raised to the power 2 plus 540 times 0.01 raised to the power 3 plus 1215 times 0.01 raised to the power 4 plus 1458 multiplied by 0.01 raised to the power 5, and finally plus 729 multiplied by 0.01 raised to the power 6. Okay, so this is the ideal way to go about carrying out this particular expression. So if we want to do that, this will be in the first entry we have 1, in the second entry 18 times 0.01, we'll put those decimal places in front of 18 itself, so we have plus 0.18, okay, plus, students, just be careful when you are trying to solve this out, okay. Here we have 135 times 0.01 raised to the power 2, so I have 135 times 0.01 raised to power 2, that's equal to 0.0135 plus, here I have 540 times 0.01 raised to power 3, so 540 times 0.01 raised to power 3 should be shift s squared. Okay, so this is now 5.4 times 10 raised to power minus 4 times 10 raised to power minus 4 means it is 0 in 4 places, so we have 0.00012354, okay, plus 1215 times 0.01 raised to power 4, so 1.215 times 10 raised to power minus 5. So I have decimal place in 5 places, and then I can write 1215. So I have 0.1234, then I have 1215, okay, plus just be careful in trying to express this out, so we can just continue on the next line. So we have it is that plus, here we have 1458 times 0.01 raised to power 5, okay, so this is 0 in 7 places, then 1458, so 0, 1, 2, 3, 4, 5, 6, and then the 7th one will be 1458, and then finally the last term 729 multiplied by 0.01 raised to power 6. Okay, so now it is in 10 places, and we'll still add that 729 maintained. So we have 0.12345678 and then the third one will now be 729. Okay, so let's try and evaluate this very carefully so that we don't make mistake. We have 1 plus 0.18 plus 0.0135 plus 0.00054 plus 0.00001215, okay, plus this now 0.1234561458 123456145, okay, plus this last entry. Now we can move our calculator to see that clearly. Okay, plus 0.12345678 123456789, then 729. So this is what 1.19405. So this is 1.19405. But we are asked to find it correct to 4 significant figures. So okay, this is good and fine, but recollect that from the question we are told to find it correct to 4 significant figures. And what's the meaning of that? That means that the number of relevant digits we should be seeing should be only 4. So here, if we want to take 4, we'll take 1, 2, 3, 4. So that will be approximately 1.194 correct to 4 significant figures as requested. Okay, so this is the solution to this question, and we're able to find it because we're able to successfully carry out our binomial expansion. But more importantly, we're able to also compare to get the value of x as 0.01, not at 0.3, and with that we've been able to solve this question on binomial expansion. In this question on transformation, we are told that given the transformation m on x, y to be defined as 7y, 3x minus y, and transformation n on x, y to be 2x minus y, 5x plus 3y, In the first case, we have to write down the matrices M and N of the linear transformations. Then we have to find the image of P, which is defined as 2, minus 3, under the linear transformation N followed by M. Then we have to find the coordinates of the point Q, whose image is Q prime for 2, 4 under the linear transformation N. So, students, we need to understand what we are doing when we are talking about linear transformation for us to be able to perfectly understand this particular question that we are looking at. And we've actually done graphical illustration on transformation on the Cartesian coordinates, and you can do it to check out those videos on our playlist on linear transformation and matrices. So you will have a very good grasp of what we are talking about when we are having linear transformation like this. But as a general rule of thumb, linear transformation is actually ways to move around the space, especially in this case, we are looking at the 2D Cartesian plane, in such a way that your grid lines remain parallel and evenly spread and your origin remains fixed. So if we just have, let's say we have this Cartesian coordinate and it is defined as X and Y, okay. Now if we take a particular point, okay, if we take a particular point here, and we are to carry out a linear transformation, that means that for this linear transformation, we can have some transformation carried on this. Maybe you can transform it from this particular, if this is A, B, we can transform it to the other side to be here, we'll have it as minus A, B, or it can come here to be minus A, minus B, or it can also be here to be A, minus B. So these are just linear transformation in which we are using a matrix to work or operate on this particular given vector so that it will transform it from this coordinate on the Cartesian plane to this particular location, or it can be from here to here, or it can be from here to here. And this is employed by making use of the matrix. So matrix is a very good way to translate transformations on the Cartesian plane, or we can say that matrices are a very good means of translating a transformation in our space. So for this particular question that we are being told that we should write down the matrices M and N of the linear transformation. Look at this. M is defined such that it will transform X, Y into 7Y, 3X minus Y. Okay. Now, if you look at this, what are we going to operate on XY to give us 7Y, 3X minus Y? If you recall your product of matrices, this is as if we are having X and Y, okay, but we are looking for the matrix M that is going to give us 7Y. Okay, let me just write that to include the argument of X. X is not here, so we have this as 0x, okay, so we have 0 plus 7Y, and here we have 3x minus y. So looking at this, what matrices are we going to have here that will multiply xy to actually give us this result? That is what they're actually asking for. And if we want to get that, we will see that here, that means that we have 0 here, okay, we have 7 here, and here we have 3, and here we have minus 1, such that 0 times x is 0, okay, then 7 times y is 7y, and 3 times x is 3x, and minus 1 times y is minus y. This is how we actually carry out our transformation, and it is a very good application of matrices. So that is actually M. M is defined as 0, 7, 3, minus 1, okay. And in the second case, for N, we can also define our N to be, we were told originally that N is operating on x, y, such that it will transform it to 2x minus y, 5x plus 3y. So again, we need to get that matrix that will operate on x, y to give us, in the first case, 2x minus y, and in the second case, 5x plus 3y. Once you are able to have a good understanding of this, then matrices and transformation will be on your graphs. Here you can see that it is 2 that we have here, and we have minus 1 here, and here we have 5, and we have 3 here, such that 2 times x is 2x, minus 1 times y is minus y, then 5 times x is 5x, 3 times y is 3y. This is how we actually go ahead to try and define our transformation. So the matrix M is this one here. Okay, so I can say M is defined as 0, 7, 3 minus 1, whereas our N is defined as 2 minus 1, 5, 3. Okay, that is the solution to question A. So this is A. Okay, so now we can move on to question B, in which we are asked to find the image of P, which is defined as 2, minus 3 under the linear transformation N followed by M. But if we want to carry out the operation N on P, we can say, so this P will translate to 2 and minus 3, such that the transformation of N on 2, minus 3 is going to give us the matrix of N, which we got initially as 2, minus 1, 5, and 3, is going to be operating on 2 and minus 3. And this we can evaluate to say it's going to give us 2 times 2 here, 2 times 2, okay, plus minus 1 times minus 3. So we can say it is plus minus 1 times minus 3, okay. Then here, 5 times 2, 5 times 2, plus 3 times minus 3, 3 times minus 3. This is the way to go about carrying out the multiplication of vectors, in which in the first case, the first row of the first matrix is multiplying the column of the second matrix, and after doing that, we will also carry out the operation by using the second row of the matrix, the first one, to multiply the column of the second matrix. So if we simplify this, we can say the operation of N on 2, minus 3 is going to give us here 2 plus 2 multiplied by 2 is 4, then plus minus 1 multiplied by minus 3 is plus 3, okay. 5 multiplied by 2 is 10, then 3 multiplied by minus 3 is minus 9. You need to be consistent with your sign so that you don't make mistakes. So if we evaluate this, this is 4 plus 3 is 7, and 10 minus 9, that is 1. So the linear transformation of N on P is this. So this is the image of P under the linear transformation N. But we also need to follow that by the linear transformation of M on this particular evaluation that we just do. So we are going to have it that in the second case, we are now going to have M to be operating on 7, 1, okay. And if M is operating on that, it will be that we are having it to be the linear transformation matrix of M, which we got initially to be 0, 7, 3 minus 1, multiplying by 7, 1. Again, we are going to multiply the row multiplied by the column. So we have 0 times 7, 0 times 7, okay, plus 7 times 1, 7 times 1, okay. Then for this, 3 times 7, 3 times 7, plus minus 1 times 1, minus 1 times 1, okay. So if we are to evaluate that, that's going to give us 0 multiplied by 7 is 0, 7 multiplied by 1, that is 7, 3 multiplied by 7 is 21, minus 1 multiplied by 1, that is minus 1. So we have this to be 7 and 20. So the linear transformation of N followed by M on P, which is defined as 2, minus 3, is 7, 20. So that is the solution to this particular second question B as requested in this question. So we can write it to say the image P prime is 7, 20. Okay. Now in this third case, we are asked to find the coordinate of the point Q, whose image is Q prime as given as 2, 4 under the linear transformation N. So already we are given the image. So what we are looking for is Q, and we say that is X, Y. As what we are looking for, we are told that Q prime is 2, 4 under the linear transformation N. So here our task is to find the coordinate of Q when the image of Q is 2, 4. So that means that originally you want to find a transformation on x comma y such that what we have is that we're having the product of the matrix n, which we got initially to be 2 minus 1 5 3, multiplying x y to give us 2 4. Okay, so this is the interpretation of the transformation, the linear transformation of n on q. So that's why we're having this matrix multiplying q to give us the image of q as 2 4. So this we can actually multiply out to get a set of simultaneous equations that we can solve to get the value of x and y, which define the coordinate of q originally. So that's what we are going to do now. We are going to multiply this row with this column, and for us to do that, we are going to have 2 times x, that will be 2x, okay, minus 1 times y, that will be minus y, is equal to the first entry here, that is 2, okay. Then we are also going to multiply this row with this particular column to get this answer, and for that case we are going to have 5 multiplied by x, that is 5x, then 3 multiplied by y, that is plus 3y, is going to give us 4. All right, so from here we can choose whatever method is suitable for us to try and solve this particular question. Okay, so if I call this equation 1 and I call this equation 2, I can say let me have equation 1 multiplied by 3. So if I have equation 1 multiplied by 3, because I can see that this is minus y, so if I get it to be minus 3y, I can add the 2 so that I can solve for x, and then I will have an head. So 2x multiplied by 3 is 6x, minus y multiplied by 3 is minus 3y, then 2 multiplied by 3, that is 6. So this, if I take the equation 2 and this equation 3 and I add them together, I'm going to have 5x plus 6x, 5x plus 6x, okay, and here plus 3y minus 3y, you can see that that's going to cancel out. So this is going to give me 4 plus 6, and that is 10. From here, that means 11x is equal to 10, such that x is 10 over 11, okay. But then from equation 1, I can see readily that from 1, if I make y the subject of the formula, y is going to be 2x minus 2. Therefore, y will be 2 multiplied by 10 over 11 minus 2, let's say 2 over 1, okay. And here, 2 multiplied by 10 over 11 is 20 over 11 minus 2 over 1. We can find the LCM such that I can say 11 is my LCM. 11 divided by 11 is 1. 1 times 20, that is 20, minus 11 divided by 1 is 11. 11 times 2, that is 22. So this is going to give me 20 minus 22, that is minus 2 over 11. All right. So that means that the coordinates of the point Q that we're told is x comma y, which we are looking for, is nothing but what's the value of x? 10 over 11, and the value of y is minus 2 over 11. And with that, we have been able to find the coordinate of the point that we apply the linear transformation n on to give us the image 2, 4 by solving for this simultaneous equation and arriving at our final answer. So this is how you go about solving questions on linear transformations, and you can watch out for more videos from us on this particular topic, right? In this question on binomial probability, we are told that in an examination, 60% of the candidates passed. If 10 candidates are selected at random, we are to find the probability that at least 2 of them failed, exactly half of them passed, at most 2 of them failed. Now, so this is a classical example on binomial probability in which we can evaluate the probability of getting R success in n repeated trials in an exercise with 2 possible outcomes. And here you can see our 2 possible outcomes is that it's either the candidate fail or the candidate pass. So those are the 2 possible outcomes. So the probability of R success in these n repeated trials is given as n combination R multiplied by the probability of success raised to power R multiplied by the probability of failure, which will be 1 minus probability of success raised to power n minus r. So this is the formula that can effectively help us to solve this particular question, and we can take the question piecewise. Okay, so in the first case, in question A, we're told that we have to find the probability that at least 2 of them failed. Because before we start looking at the probability of them failing or passing, let's get the probability of failure and pass. Okay, here we are told that 60% of the candidate pass. So the probability of success, which I can call P, is going to be 60 over 100, and 60 over 100 we can evaluate to be 6 over 10, and I can use 2 to divide that. That will be 3 over 5. Okay, that's the probability for success. And if that is the case, then the probability for failure, which I'll call 1 minus P, or I can call it Q, that's going to be 1 minus the probability for success, which is 3 over 5, and in that case that will be 2 over 5. So this is the probability for failure, and that's what we are going to be using in this binomial expression, like n combination R. P we have gotten to be 3 over 5, then 1 minus P, that will be 2 over 5. So in the first case that we're looking at least 2 of them failing, that probability, the probability that will capture that event, will mean that for the people that fail, at least 2 of them fail, means that 2 or 3 or 4 or 5 or 6, 7, 8, 9 or 10 are the people that failed. Okay, so out of those 10 that we are looking at, we are saying 10 candidates are being selected at random. So at least 2 of them failed means that the minimum number of those that failed is 2. That's why we have 2 here up to 10. So that would have warranted that we need to start saying that is probability of 2 failing, which is the event, x is equal to 2, plus probability of 3 failing, okay, plus probability of 4 failing, up to probability of 10 failing. Okay, and you can see this is going to be very Herculean, and that is not a smart approach to actually take. Or instead of doing that, because we know that probability always add up to 1, we can say this particular probability of the event that at least 2 of them failed, we can express it as 1 minus the probability that x less than 2. Why are we saying x less than 2? You can see here it is x is equal to 2, x is 3, x is 4, up till x is 10. That is what we have expressed here. 2, 3, 4, 5, 6, 7, 8, 9, 10 are the case scenarios in which they fail. So the other scenarios will be the scenarios in which 0 failed or 1 failed. That is x less than 2. So this will be 1 minus the probability of x is equal to 0. In that case, none of them failed. Okay, then we need to just put this in brackets, minus the probability that 1 of them failed. Okay, so this particular scenario is the scenario that 0 failed, no student failed here. Okay, and here it is that 1 student failed. So you can see, if we really want to express that, we can say this will now be 1 minus, we need to put everything in bracket. So the probability that 0 failed will be 10 combination 0, but now the failure is 2 over 5. This is the expression for the failure, 2 over 5. So we have 2 over 5 raised to power 0, and if 0 failed, that means all of them pass. So we can have 3 over 5 raised to power 10. All right, so that is for this particular case scenario. Then plus this is plus, this is not minus, this is plus. We are having those two scenarios. So here plus 10 combination 1, and then the case in which 1 failed, that will be 2 over 5, which is the probability for failure raised to power 1, multiplied by 3 over 5 raised to power 9. And you can see the consistency in this, that the addition of the power of the two probabilities 0 and 10, that will be 10, 1 and 9, that will be 10. So this is what we need to evaluate to effectively solve this particular question as appropriate. Okay, so here we can say we have this expression as a probability for at least 2 of the student failing to be 1 minus this particular probability in which none fails and all pass, and the probability in which 1 fail and 9 of them pass. So if you want to evaluate this will be 1 minus. So in this first case, 10 combination 0 is 1. Any number raised to power 0 is also 1. So we need to evaluate 3 over 5 raised to power 10. So 3 over 5 raised to power 10. Okay, that's what. So this is exponent of minus 3 means it is decimal places in 3 places. So we have 0, 1, 2, 3 of 6, 0, 4, 6 is 1. So this is 0.12604661, okay, plus 10 combination 1. You can get that from the calculator to say 10 combination is this button for the division, but we need to use shift with it. So we have 10 combination 1, and that is equal to 10. Okay, so we have plus 10 multiplied by 2 over 5 raised to power 1 is 0.4. Okay, this is just 2 divided by 5. Then 3 over 5 raised to power 9, we can evaluate with the calculator to say we have, let's open our bracket. Here we have 3 over 5. And close that bracket. Then raised to power 9, that's what? 0.010077696. 0.0100, let me check that, 77696. 77696. So this is the expression for that particular probability. So we can have it as 1 minus. Okay, you could have just say you want to open up this bracket, or you just want to evaluate that straight. So we have decimal place 1, 2. Okay, so I can say 0.06046 is 1 plus, now I want to put this in bracket, 10 times 0.4 times 0.010077696. Close the bracket. So this is supposed to be 60. So you can solve that. So this is 0.046357. 0.046357 394. This is what we need to subtract from 1 to get our final answer, and I can say 1 minus just this previous answer. That's 0.95364. 0.95364 2606. 2606. So you can just take a suitable approximation. I think I'll be sufficient to use 4 decimal place. So I will say this is 0.9536 as the solution to this particular question. Okay. So now in question B, we are to find the probability of the event that exactly half of them pass. So that probability that half of them passed the exam. And if you look at what we are dealing with in the binomial probability, that will be 10 combination 5. Then the probability that half of them pass, 3 over 5 raised to power 5. Then the probability that half of them fail, 2 over 5 raised to power 5. This is quite straightforward, quite direct. So you can say we want to express that to say this is going to give us, what's 10 combination of 5? 10 combination shift divided 5 is equal to 252. So this is 252 multiplied by 3 over 5 raised to power 5. 3 over 5 is 0.6, so I can say 0.6 to the power of 5. So this is 0.0776, 0.077, is that 2 or 3? 7776. Then multiply by 2 over 5 raised to power 5. That is 0.4 raised to power 5. So 0.4 to the power of 5. And this is 0.01024. 0.01024. And if you are to multiply all of them together and just approximate to 4 decimal place, we'll have it as, let me see, 252 times 0.07776 multiplied by 0.01024. Okay, so this is 0.200. I want it in 4 decimal place, so I can round off 5 to, I will round it up to 1 and add to 6. So this is approximately 0.2007 as a probability that exactly half of them passed. Okay, so we are almost through. Finally, in the third case, we have to find the probability that at most 2 of them failed. The probability of at most 2 of them failed, the probability of that event that is described in C, is going to be that first, at most 2 of them failed means that we are going to have none of them failed, okay, plus only one of them failed, plus 2 of them failed. Okay, that's what I'm trying to express in this particular case. So in the first case, at most 2 of them failed means that the maximum number of those that failed is 2. And if that's going to occur, we are going to first have a case in which none of them fails. That's why we have x is 0, none failed. Okay, so I can just note and append that this is none failed. And here, then after that case scenario, we also have the probability of only one of them failing. So here we have 1 failed. And finally, we have that they say at most, then in this case 2, which is the maximum number for this condition, 2 failed. But you now need to know that the event we are looking at here is failure. So we are going to be looking at 2 over 5 as the event that we are determining here. So instead of using the probability for the success, now 2 over 5, which is the failure, that is what we are looking at here that we should actually take note of. So if you want to find this, you can just say this is going to give us, in the first case, it is 10 combination 0, then none failed will be 2 over 5 is none, multiplied by, if none failed, then all of them passed, so that will be 3 over 5 raised to power 10, okay, plus in the second case 1 failed, so we have 10 combination 1 multiplied by 2 over 5, which is for failure, raised to power 1 failing, then 3 over 5 raised to power 9, okay. And then for the third case, we have 10 combination 2 multiplied by 2 over 5 raised to power 2 are now failing, then multiplied by 3 over 5 raised to power 8. Okay, so that is the ideal way to go about solving this. And I'm going to just input this directly in the calculator. We've been working it together. So now I just want to get the value straight. I'm even running out of space. So I'm going to have 10 combination 0, 2 over 5 raised to power 0, which is 1. This is 1. 10 combination 0 is also 1. So I just need 3 over 5 raised to power 10. So let me just say I have 3 over 5. Yeah, 3 over 5 raised to power 10. That will be quite enormous. Okay, so 0.00604661. Looks like we worked with something like that before. Okay, 0.00600417 plus, in this second case, 10 combination 1, that is 10, 2 over 5, I will just say it is 10 times 2 over 5 is 0.4, 0.4, okay, times 3 over 5 raised to power 9. So I have here 3 and down 5, and close that bracket, to the power of 9. Okay, so I'm just evaluating them straight. This 0.0403, 0.0403, 10784, 10784, plus in the third case I have 10 combination 2. Let me just write this straight. Okay, so I have 10 shift division. Okay, 2 multiplied by 2 over 5. Here we have it to the power of 2, that's square. Then multiply by 3 over 5 and close that bracket, to the power of 8. Okay, so this is the whole expression for this third entry, and if I press equal to, maybe I should just put my multiplication sign here, so times, okay, good. So it's actually expecting me to put the multiplication sign there. So I have this at 0.12093, 0.12093, 2352. So these are the entries that I need to add together. I'm running out of space, so I'll just move that now. So I can just find the approximated value of this, and I'll just have it as 0.00604616. Okay, 0.0064 604 6617 6617, plus in the second case 0.0403, 0.0403, 0403. Okay, I think I can see others directly now. 10784, then plus 0.1209 32352. All right, so this is 0.167289, approximately to 4 decimal place. 8 will be rounded up to 1 and added to 2, so I have 0.1673. so this is 0.1673. okay, all right. So in this case, this is the solution for question C, and this is the solution for question B. So just like that, we've been able to look at the probability of R success in an n repeated value in which we have exactly two outcomes for the event that we are looking at. The two outcomes here is that students either pass or fail, and then we are picking 10 candidates out of those particular sets, and we can use the binomial theorem, the binomial probability, to successfully evaluate that as shown in this particular example. Here is a question on the Spearman's rank correlation coefficient, and we're told that in a research to determine the relationship between performance of students in an entrance exam and the subsequent school performance, the result of 10 randomly selected students were obtained as follows. So we can already say that we have the number of students that we are looking at here, that n is 10, and note that. So this is actually the table for the scores in the exams, both the entrance exam and the school exam. So now we have to calculate the Spearman's rank correlation coefficient and find what the researcher's conclusion from the result in A is going to be. So to find the Spearman's rank correlation coefficient, we make use of the formula R is equal to 1 minus 6 multiplied by the summation of the deviation square over n multiplied by n square minus 1. And we have already seen that the number of students is 10, so we have n, but we need to get the deviation. However, the deviation is not just gotten by subtracting the marks from each of the exam. It is that we first rank the marks. So that's why we're talking about the Spearman's rank correlation. Is the rank, in which case is the student performing best, followed by which one, followed by which one. It is the ranking, not the scores. So we are going to get our table to get that now. So this is what our table is looking like, and we have tabulated for the student, and then this is the performance in the entrance exam in this second column, and this fourth column is the performance in the school exam. So now we need to rank the performance in the entrance examination and the performance in the school examination. Then we'll find the difference between the two, which will be our deviation. Then we can find the square of the deviation, which we can sum to use in this equation. All right, so if you want to rank this now, we can see that where is the highest mark? 17 is the highest mark. So this will take the rank of 1, because that is where the student scored the highest. Student I scored the highest. So is number 1 is position 1, and the second is J, and then the third is 15. Okay, and then number 4 will have to be 14. Number 5 will have to be 13. Number 6 will be 12. Number 7 will be 11. Number 8 will be 10. Number 9 will be 8. And number 10 will be 6. So this is the ranking that we make use of, not the scores in the exam. And then in the school performance, who is the best student, who comes first in this particular exam? The highest mark, we are saying it is 14. Okay, so this is number 1, then followed by 12, this is number 2, followed by 11, number 3, then 10, this is number 4. Do we have 9? Yes, this is number 5. 8, this is number 6. 7 is number 7, 7. Okay, then 6 will have to be number 8. Okay, 5 is number 9, and 4 is number 10. So it is this ranking that we now look at to find the deviation that we will be using. So the deviation will be 7 minus 9, that is minus 2. Okay, 6 minus 4, that is 2. 9 minus 5 is 4. 5 minus 7 is minus 2. 10 minus 10, that is 0. Okay, then 3 minus 6, that is minus 3. 8 minus 8 is 0. 4 minus 1, that is 3. 1 minus 3, that is minus 2. Then 2 minus 2, that is 0. Then we need to find the square of this deviation. So minus 2 raised to power 2, that is 4. 2 raised to power 2 is also 4. 4 raised to power 2, 16. Minus 2 raised to power 2 is 4. 0 raised to power 2, 0. Minus 3 raised to power 2, that is 9. 0 raised to power 2, 0. The square of 3 is 9. Minus 2 raised to power 2, that is 4. And 0 raised to power 0. 0 raised to power 2, that is also 0. So this is the square of the deviation that we need to add, and we can say, let's just use our calculator so that we don't make mistake. And say 4 plus 4 plus 16 plus 4 plus 0 plus 9 plus 0 plus 9 plus 4 plus 0. Okay, so this is 50. So we can see that summation this square is 50. Then we can evaluate the Spearman's rank coefficient as 1 minus 6 times the summation of this square is what we just want to be 50 over n is 10. Then n square will be 100 minus 1. So if you are to find this and look at it critically, I can just put this in my calculator, or a student, you can choose to evaluate this first. You can say, okay, this is now going to be 1 minus 10 here, 1, 10 in 50, that is 5. 6 times 5 is 30, so this is 1 minus 30 over 100 minus 1 is 99. 3 can go here, 10. 3 can go here, 33. So we have the ranking to be 1 minus 10 over 33, and that will be 33. Here we have 33 minus 10, which is 23 over 33. So 23 over 33 is the value here, but I can just say I want to put that in decimal because that will be more suitable for us. So 23 divided by 33 So that is 0.69, meaning that this bar means that it is repeated. So we can say it is approximately 0.697, okay, at the Spearman's rank correlation coefficient. So in the second case, this is question A. In the second case, we are now being asked that what will be the researcher's conclusion from the result in 13A? Let's look at this together, because the rank coefficient is actually trying to help us evaluate how the performance in one exam in this particular case and the performance in the second exam, how they correlate. Are they correlating well in such a way that the student that came first also came first in the second test, the student that came second also came second, third, the person also came third, okay? So if we are to even look at this, we can see here candidate H came first here, but he came third here. However, candidate J came second and also came second here. Look at this last candidate. He came 10th here, he also came 10th here. So we just want to look at how is the relationship between those two. So if we want to conclude, we can have R to be either +1, 0, or -1. This is the scale that we can use. If it is +1, there is a perfect correlation. If it is 0, there is no correlation. If it is -1, there is negative correlation. So the more positive the number, the better the correlation between the set of values that we are comparing. If it is 0, then there is no correlation. If it is negative, there is negative association. They are not even associated at all. But for this particular question, we can see that 0.697 is what we got as our Spearman's rank correlation coefficient. So the conclusion of the researcher should be that the relationship between the performance in the entrance exam and that of the school exam is fairly positive. So you can just have that, and with that you could have been able to get quite a good juxtaposition of the comparison of the student performance in the entrance examination and that of the school examination. All right. Here is a question on the velocity time graph in mechanics, and we are told that a body moving at 20 meters per second accelerates uniformly at 2.5 meters per second square for 4 seconds. It continues the journey at this speed for 8 seconds before coming to rest 3 seconds after that with uniform retardation. If the ratio of the acceleration to retardation is 3:4, first we have to sketch the velocity time graph of the journey, we have to find t, and we have to find the total distance of the journey. So let's bring our ingenuity of our understanding of the velocity time graph to bear in this particular case. We just try to give some sketch as they are requesting from us. So if you draw the velocity time graph with the time on the horizontal axis, just like this, this is the time, and then the velocity on the vertical axis, this is the velocity. We can just label as appropriate that this is v in meter per seconds and this is t in seconds. Okay, now to interpret the information that we're given, we're told that a body moving at 20 meters per second, so the initial velocity that the body is starting from is 20 meters per second. Okay, so we can say this is 20 meters per second. Then from there it accelerates uniformly at 2.5 meters per second square for 4 seconds. So if I'm to take my gradation here and say this is like 4, this is another 4, another 4, just taking a gradation of 4. Okay, so I can say that there is an acceleration from the starting velocity to a new velocity. Okay, and the time for that was actually 4 seconds. So this will be 0, this is 4, so this is 4 seconds, and by that 4 seconds it had gotten to this particular location here, which I can denote like this. Okay, then we're not told that after doing that, this same body is just continuing the journey at this speed for 8 seconds. Now to interpret 8 seconds means that 8 in addition to that 4. So it's not that it's stopping at 8, it is that we have to add 8 to 4, and if you add 8 to 4, that will be 12. So if I say this is the 8th mark, this is the 12th mark, it is 8 plus 4 that is giving me 12. So this is where it's going to get to, and I can denote that by just drawing on the velocity time graph, okay, and then I can just point this down that yes, this is on the 12-second mark, okay, so we are getting on point. So we are not told that the body comes to rest 3 seconds after that with uniform retardation, okay. Uniform retardation means that the movement from this particular point where we have gotten to the point where the velocity is 0. Here, this is the origin where that velocity is 0, so it moves with a uniform retardation. So that we need to dip nose down, okay, that would nose dive. I'm just taking this arbitrarily, I don't know what that value is going to be. So that is the uniform retardation, and it comes to rest 3 seconds after. So 3 seconds after means that from here to here, okay. So this is going to be, please, you need to note this. So it is from here to here, that is t. That's 3 seconds after the time consideration that we are looking at, okay. So this is the very first thing that we have to find to sketch the velocity time graph of the journey. But I want to include the acceleration. In the first case, we are told that the body moving at 20 meters per second, accelerates uniformly at 2.5 meters per second square. So here, this is 2.5 meters per second square, okay. That's 2.5 meters per second square. Then here, the retardation here, we are told that the ratio of the acceleration to retardation is 3:4. So acceleration to retardation is 3:4. Therefore, if you cross multiply, the retardation will be 4a/3. But acceleration was given as 2.5. So the retardation is 4 times 2.5 divided by 3. 4 times 2.5 is 10, okay. So we have this as 10/3, and that will be 3.33 meters per second square. So here, this particular slope is 3.33 meters per second square. So we need to just capture that so that we will be able to know what we are going to be working with respect to acceleration and deceleration. Now, that is the velocity time graph. Then we are asked to find t, okay. If you are to label our diagram and call this point A, this is point B, this is point C, and here this is point D, okay, we can solve for the velocity here. We can find this final velocity V, okay, that is the final velocity that the body attained to and moved uniformly with for these 8 seconds that we are given. And that slope, since we can get here, we can actually use it in this particular region to find the value of t, okay. So we want to solve for the B. From the velocity time graph, what we will notice is that if we consider the line AB, which is actually the slope of the graph, it is actually the change in velocity over the change in time, okay. So now look at this. If we just take this here, we can look at it as if we have a triangle. AB was given as 2.5, okay. We were told in the question that this is 2.5. It is the change in the velocity, that is the V, the final velocity here, minus the initial velocity is moving from, that is 20, over the change in time. So our time was starting from 0 and ending at 4. So this is over 4 minus 0. So we can say we want to cross multiply by saying this is over 1. So 4 minus 0 is 4. 4 times 2.5 is 10. So 10 is equal to V minus 20, such that the velocity is 10 plus 20, and that is 30 meters per second. So V here is 30 meters per second, but what we are looking for is the time t in this particular case. So we can say, if we look at, if we now consider the line, and this is how you actually work with the velocity time graph. If we consider the line CD, also we will see that this line CD is the slope such that CD is equal to change in that velocity over the change in time, okay. Change in t, it is from here to here, that is t. Then from here to here, that is gotten as 40. So we can say, therefore, CD, which is 10/3, I can use 10 over 3 directly instead of 3.3. 10 over 3 is equal to, what's the change in velocity? The change in velocity will be from this final velocity v that we got as 30 meters per second down to the point at which the body is at rest, which is 0. So we can have it as 30 minus 0 over, what is the change in t? Initially, the time is at 12 seconds, but now we don't know the final one. But the difference between them is this particular time, t. Okay, so it is just t. Don't say that this is t minus 12. That means we are considering the whole of this particular diagram. We just want to look at this triangle here, this one here. So the change in velocity is from 30 to 0, and the change in time is actually the t. This t is a change in time. So by the time we look here, I will say we want to just cross multiply. If we cross multiply here, we can say that 10t is equal to 3 times 30, that is 90. Therefore, t is 90 over 10, and that is 9 seconds. Okay. So now, in the last question, we have to find the total distance of the journey. The total distance is going to be, the area under the graph. So this is actually, the total distance is the area of the particular shape that we have here. And we can see that that is taking us to find the area of this. Let me just further label this A, B, C, D. You can say this is E and this is F. So this is O, the origin where we are coming from. So it is the area of the trapezium ABFO, this first one here, ABFO, okay, plus the area of the rectangle BCEF, plus the area of this triangle. Wow, this is interesting now. This area of this triangle CED. Now this is a trapezium, this is a rectangle, and this is a triangle. So it is the sum of these areas that we want to find to actually get the area under the graph that is going to give us the total distance covered by that particular object. Now, already we have seen that we have all the values that we have. V here is 30, then we know t. This t we have just gotten to be 9. So we can go ahead to look at that area. In the first case, the area of the trapezium ABFO is half the sum of the parallel sides multiplied by the height. So where are the parallel sides? We have, for this particular trapezium, the parallel side will be this and this OA and BF. So that will be OA is 20, so I have 20, plus BF is 30, so I have 30, multiplied by the height. The height is now from 0 to 4, and that is 4. Okay, so that's the first case, plus the area of the rectangle BCEF. Now this length is 12 minus 4, which is 8, so I have 8, multiplied by this height is 30, so it's 8 times 30, then plus the area of this triangle CED, and I can say it is half base times height, so I can say that is 1 over 2. The base is t, which we got to be 9, then the height is EC, which is 30. Okay, so for students, if you want to get that, this is actually half the sum of the sides multiplied by the height for the trapezium. Here it is the length multiplied by the breadth for the rectangle, and here it is half base times height for the triangle. So this is what we're actually doing, and we're finding the area under the graph, which will correspond to the total distance traveled for the particular body. So if you want to evaluate that, this is 2 and 4, that will be 220 plus 30 is 50, so we have 2 times 50 here, plus 8 times 30 is 240, okay, plus half of 30 is 15, so we have 15 times 9, and we can just solve that. 2 times 50 is 100, plus 240 plus 15 times 9 will be 150 minus 15. 150 minus 15 is 135. So the total distance covered will be 100 plus 240 is 340. 340 plus 135, 340, 135, that is 475k. So for this particular question, in this velocity time graph, the total distance covered is 475 meters as taken from the graph. This is how we actually go about solving questions on the velocity time graph, and we have been able to find the acceleration, the retardation, the unknown time, and then the total distance covered. All right. In this question on vectors, we are given that m is I minus j, vector n is 2i plus 3j, and 2m plus n minus r is equal to 0. We are to find the modulus of vector r. Okay, no problem with that. It's just an algebra process on vectors. But from the question already, we can see from this particular expression here, since we are looking for the modulus of r, we can find r, and then we'll be able to find its modulus, its magnitude. Okay, or to find the magnitude of r. In this question on vectors, we are told that given that m, the vector m is I minus j, the vector n is 2i plus 3j. Good morning, good morning. In this question on vectors, we are told that given that vector m is I minus j, vector n is 2i plus 3j, and 2m plus n minus r is equal to 0, we are to find the magnitude of the vector r. No problem. What we just need to do is that from this expression, we should be able to find r, and from r, we should find the magnitude of that vector r. So if you want to start from here, we are given 2m plus n minus r is equal to 0. So to make r the subject of the formula, we can say therefore r moving to the other side will be r is equal to 2m plus n. But from the question, look at the question here, we're giving m to be I minus j and n to be 2i plus 3j. So in that case, r will be 2 multiplied by m, and that is I minus j, okay, then plus n, which happens to be 2i plus 3j. Okay, we can open this bracket to say this will become 2i minus 2j plus 2i plus 3j. So if we take the component wise, 2i plus 2i, that will be 4i, okay, then minus 2j plus 3j, that will just be plus j. So this is the expression for vector r, but that's not what we have to find. We have to find the magnitude of that particular vector. So to find the magnitude, that is expressed as the square root of the sum of the square of the components, and the component here, the first one is 4, so we have 4 raised to the power 2, and here the component is 1, the j component is 1, so we have 1 raised to the power 2. So this is going to give us the square root of 4 raised to the power 2 is 16, 1 raised to the power 2 is 1, so the magnitude of r is the square root of 17. You can leave your answer like this, or you can say you want to use your calculator to find root 17, and that is 4.1231. So you can say this is also equal to 4.1231, and with that you've been able to answer this question on vector algebra. In this question on differentiation, we are told that the distance s in this question on differentiation, we are told that the distance s meters of a moving particle at any time t seconds is given by s equal to 3t minus 3 to the power 3 over 3 plus 9. Now we have to find the time and the distance traveled when the particle is momentarily at rest. So our understanding of how to interpret this question is going to help us to solve it, because we are told that it is a moving particle, but then we are looking at a case scenario when it is momentarily at rest. But what we are given is the distance. So s is the distance that we are given as 3t minus t raised to the power 3 over 3 plus 9. Okay, so that is the distance of the particle. But we know when we're talking about the particle coming to rest, that means there is a change in its rate of movement. The rate of movement means there is a change in its velocity, and velocity is the rate of change of the distance with respect to time. So the velocity is the s dt And if you want to find the SDT in this particular case, generally as a rule of thumb, if you have a multiplied by x raised to the power n, the differential of this particular expression with respect to x, if y is this, the differentiation of y with respect to x will be a multiplied by n, which is the power, then the power will be reduced, multiplied by x, and then we'll reduce the power by 1. So if you are to make use of that in this particular case, we are going to have this, that it is going to be the differential of 3t is 3, okay, because t is like t raised to the power 0, and when we are subtracting, t is like t raised to the power 1, and when we are subtracting another one from it, that's t raised to the power 0, which is 1. So we only have 3 here. Then here in this case, minus, here we have it as the 3 will come down, then we have t raised to the power 2 over that particular 3. The differential of a constant is 0, so this is actually not going to take any effect. So we have this to be 3 So we have this to be 3 minus t squared, because the other two 3's here, this and this, they will cut off. So this is the expression for the velocity. Now look at what we are being told in the question. First and foremost, we are being told that the particle is momentarily at rest. So at rest, just momentarily, the velocity is going to be 0. Therefore, we can say 3 minus t squared is equal to 0, such that our t squared is going to be 3. So for this, we can just say t is going to be the square root of 3, and the decimal point, that will be 1.732. That's 1.73205 seconds. Okay, good. We could have leave that as root 3, but no problem. However, in this is the solution to the first question. In the second question, now we are being asked that we should find the distance traveled when the particle is momentarily at rest. That means that we can use this value of the time t in the original expression for the distance, and we'll say s is equal to 3t minus t raised to the power 3 over 3 plus 9. Okay, so that s is going to give us, if we want to use the value of t, that is going to give us 3 root 3, okay, minus root 3 raised to the power 3 over 3 plus 9. I will just use my calculator to express this. We'll say 3 root 3, okay, then minus, I want to put this in fraction, root 3 square root of 3, then raised to the power 3 to the power of 3 shift square. Okay, you can see how that is working out. Divided by 3, then I have this plus 9. Just check to see that you didn't make any mistake. And this is 9 plus 2 root 3. Okay, I can write this as s is equal to 9 plus 2 root 3. I love the way the calculator just gave me that answer. But if I want to get it out in decimal, it will be 12.464. So this is 12.464 meters. And with that, we've been able to solve this question because we understood how we can apply the law of differentiations to solve in a case like this as appropriate. All right. So that's all we are going to be having in our lecture today. We hope that this will be of benefit, of use to somebody out there. Don't forget to subscribe to our channel. We have a lot of resources that you can use to enhance your academic excellence. And that's our desire, that you go out and be the best. And as you do all this, we know that all will work out together for good. Until next time, God bless you.